where we will be talking about isosceles and equilateral triangles. Isosceles and equilateral triangles. So first, in a isosceles triangle, an isosceles triangle has two congruent sides. These two congruent sides are called legs. Well, let's go with leg. They're each called leg, a leg. This angle up top is called the vertex angle. The other two angles in an isosceles triangle, they are congruent to each other. And those are called base angles. Those are called base angles because this third side of the triangle is called the base. It's the side that's not a leg. And then there's a theorem related to an isosceles triangle. And it says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if you see a triangle and you're told that two of the sides are congruent, you know, based on that fact, that the angles opposite of those sides are congruent. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. The converse of that is also true. If two angles in a triangle are congruent, then the sides opposite those angles are congruent. Two really important rules regarding isosceles triangles. I understand what an isosceles triangle is and what it looks like and the rules related to an isosceles triangle? All right, two sides are the same. Angles opposite those sides, those are the same as well. It's got a base, it's got a vertex angle, and it's got two legs. All right, so then equilateral triangle. In an equilateral triangle, all the sides are the same. Here's the rule related to an equilateral triangle. If a triangle has three congruent sides, then it has three congruent angles. So if you see a triangle and all the side lengths are the same, then all these angle measures are congruent to each other. And if all the sides are the same and all the angles are the same, what are the angles all equal to? What is each angle equal to? What did the three angles have to add up to? They're all equal to 60. Because if they're all the same and they add up to 180, can't you divide 180 by 3? And you get 60, right? So in an equilateral triangle, all the angles are equal to 60 degrees. So the other rule related to equilateral triangles is that if a triangle has three congruent angles, then it has three congruent sides. We're going to say up here, equilateral triangle, just put the word an equilateral triangle is also equiangular. Remember, equilateral means equal sides. Equiangular means equal angles. Equilateral is equal sides. Equiangular is equal angles. Everybody all right with that? Isn't that fascinating? I bet you woke up this morning hoping that in second block we would be talking about isosceles and equilateral triangles. Because when my alarm went off, that's the first thing I thought of was, oh, I love this day. Isosceles triangles and equilateral triangles. My breakfast tasted better because of it. Do you share my enthusiasm? No. Okay, so everybody says yes is lying. For sure, somebody even said, thank you. I appreciate your support. So where were we? Liars. Okay. So with all the excitement floating through the air, now we can do some example problems. That's just as exciting, isn't it? I see some head nods. Yeah, up and down. Awesome. Awesome. This is my favorite. That's why this is my favorite class. This is my favorite second block class. All right, so we're going to get a triangle right here. And we've got angles X, Y, and Z. Got a 60. Got an 8. Got another 8. Find the measure of angle Y. Find the measure of angle Y. So if this triangle has two sides that are equal to each other, aren't these two bottom angles equal to each other? Good. You just wrote that down. So there's some of you will say, oh, well, if those two are equal to each other and that one equals 60, well, 180 minus 60 is 120, and 120 divided by 2 equals 60. So these angles are 60 degrees each. And you would be correct. Some people do it that way. Some people say, well, angle Z has to be the same as angle Y. So let me put a variable there. And since the angles are the same, the variables are the same. And I'm going to write an equation. I'm going to say that x plus x, which is 2x, plus 60 has to equal 180. The three angles in the triangle have to sum 180. And then you could subtract 60. And you could divide by 2. And you would still get 60 degrees for each of those angles. All right? So the measure of angle Y is 60 degrees. Let's try this one. We're going to find measure angle M, and we're going to find PN for this triangle. PMN. So you've got a triangle with two congruent angles, right? What do you know about a triangle with two congruent angles? Good. The sides opposite of those angles are also congruent. So what's Pn equal to? Pn is equal to 11. Now, if angle P and angle M are equal to each other, those are both the same degree measures. So it's the same as the problem we just did, right? Your 2x plus 120 has to equal 180. So you can subtract 120. Your 2x equals 60. And then you can divide by 2. So each of those base angles would measure 30 degrees. So the measure of angle M is 30 degrees. Any questions? Yes. Why don't you say that again? Well, because you don't know what they're going to add up to. You don't know when you're talking about triangles, you know that the angles have to sum 180, but you don't know what the sides need to add up to. The only time you would know that is if it was an equilateral triangle and you knew one of the sides, and they all had to be the same. But in these triangles, we don't know what the sides need to add up to. You don't know yet. Later, when you get older, we'll teach you. Maybe like around May, when we do sine, cosine, tangent, and we do law of sines, we can find out side lengths based on angle measures and so on. That's when it gets really exciting. My breakfast tastes even better then. Oh, just getting excited thinking about it. So let's find the value of each variable now. So we got to find x, we got to find y. If you want to work alphabetically, we find x first. So looking at this triangle, aren't all the sides the same? If all the sides are the same, what do you know about all the angles? They're the same. So what's angle C equal to? Good. So how many x's do we have in here? We got 2 of them, and then 2 of them, and 2 of them. So how many we got? So don't we got 6 x's that have to sum? What do they got to equal? Good. So if 6x equals 180, you can divide by 6. What do you know about 4y minus 5 and 3? Look, a little louder. They're equal. 4y minus 5 is equal to 3. So you can add 5 to each side. And y equals 2. Everybody doing all right? All right, I got one more example to work with you, and then I'm going to turn you loose and give you some practice because I know that's what you want. You want to be cut free. Find the value of each variable. While you're writing, can anybody tell me what kind of triangle that is? A little louder? It's isosceles, isn't it? If two sides are the same, what do you know about the opposite angles? Aren't they the same? So what can I put down here in this bottom left angle? Ooh, wait a minute. These two angles right here. There you go. The angles are equal to 6x plus 8. So what do all the angles have to add up to? 180. So I'm going to do, what's a 6x plus another 6x? That's a 12x. And then we got 80 plus 8 plus 8. 80, say again. Very good. And that's all equal to 180. So subtract your 96. Somebody tell me what 180 minus 96 is. Yeah. 84 divided by 12. What's 84 divided by 12? 7. There's your x. What do we know about 4y minus 2 and 2y plus 2? They're equal to each other, right? So you can write your equation. And you can solve for y. Everybody all right with that problem? All right, very good. I'm going to give you some practice problems to do now. So in your handout or on your focus or on your pages that are on the focus, page 289. Two through 6, and then 9 through 14. Page 290. '15 through 22. And as always, you need to check focus for homework. If there are no questions from you e-learners, you are excused from the Zoom meeting to go do your assignment. Have a wonderful day, and I'll talk at you tomorrow.